Welcome to our lesson on geometric series. Of course, a geometric series is just all the terms of a geometric sequence added together. Okay, notice here's our formula for a geometric series. If you want to look at where that came from, it's on page 44. I used to have my students work through the derivation, but seemed to confuse them more than anything. So this year I'm just going to leave you a look at it on page 44. Notice that r can't be 1, which really doesn't do anything because a geometric series with r equals 1 would be like 2 plus 2 plus 2 plus 2, right? Because you'd be multiplying by 1 every time, getting the same thing. So really, we don't lose anything by r not being able to be 1. Okay, let's have a look at example 1. So we want the first 15 terms of this geometric series. Notice that our first term, t1, is 40. Our common ratio, we're multiplying by -1/2 every time. And we've got 15 terms. So S15 is going to be 40 times 1 minus. Okay, and they want that to the nearest hundredth, so we fire all that into our calculator, and we get S15 equals 26.67. Okay, exact same thing here. First term's 3, multiplying by 4 every time, and we want the first 12 terms. And in this case, we get, so what's that? 16,777,215. Notice a mistake I commonly see on these is people put in 12 minus 1 up here because they get the formula screwed up. Notice in this formula, it's just 12. It's just your n. Okay, so in this guy, telling it there are 10 terms. There's the sum. Common ratio is -3. So we know the common ratio is -3. We know that I got 10 terms, and that S10 equals -29,524. So we'll plug everything we know into the formula. And when we punch all that into our calculator, we get -14,762 T1. So we get T1 equals 2. So our first term of that geometric series would be 2. Okay, example 3, we need to calculate the sum. So we know T1 equals 6. We know R equals 2. We're multiplying by 2 every time. What we don't know is how many terms there are. So let's figure that out. It's going to be our first term times our common ratio to the power of n minus 1. So that's using our formula from yesterday. And again, same as yesterday, we don't have the math to figure this out directly, so we're going to have to guess and check. And we'll see that 2048 is the same as 2 to the 11th. So now we know we've got 12 terms in this series. And so now we can figure out S12. we figure out S12, we see we get 24,570. Okay, and question 3 is exactly the same as question 2. So the first thing we need to figure out is how many terms. Our first term is -3, and we're multiplying by 5 every time. Oops. And again, we guess and check, and we see that this is 5 to the power of 6. So we see we've got 7 terms. So S7 oops. And we get that S7 is negative 58,593. Okay, we got a little word problem here. Talking about bonuses. So in 2002, there's a $2,500 bonus. Each year after that, bonus increased by 8%. So in 2003, he would have had 8% more than that. So he would have had $2,500 times 1.08, because he would have had 108% of last year's bonus. So that gives him a $2,700 bonus in 2003. Okay, and now we want to know how much in 2010. Okay, so notice that our T1 was in, actually here, let's do it down here. So T1 was 2002. 2003 would have been T2. T3, I'm getting all screwed up here. Okay, let's go 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. So it's T3, T4, T5, T6, T7, T8, and T9. So if we're talking about the bonus for just 2010, we're talking about T9. So our T9 is going to equal our original. There's our common ratio, what we're multiplying by every year. And then that's going to be the power of 9 minus 1. So T9 is going to be $4627.33. Okay, C wants the total from 2002 to 2014. So that was 2010, 2011, 2012, 2013, 2014. So that's T10, T11, T12, T13. And if I add all those together, plus, 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 I get S13. So I'll be looking for S13 in this case. So that'll be my first term. 1 minus my common ratio to the power of 13. And then all over 1 minus my common ratio. And when we punch all that in, oops, we see that the total from the years 2002 to 2013, or 2014, sorry, give us $53,738.24. Okay, you probably noticed I spent a lot of time on this little kind of timeline versus which term thing. That's because that's probably the most common place people make mistakes on these questions. So be really, really careful about that.